Alrighty, welcome back. So we're talking about the planets, some cool characteristics of them, different missions to explore them, and things like that. In the first video, we talked about the inner planets. We also made sure we know the distinction between like mass and weight, a little bit about gravity, things like that. So now we're going to talk about the Jovian, or the outer planets, the gas giants. All right, first up is, of course, Jupiter. All right, this is our fifth planet. It's also our largest planet. What's crazy about it is just how massive Jupiter is. If you were to take all the other planets and combine them, and then multiply it by 2, it still would not be quite the same size as Jupiter. It's kind of crazy. Jupiter gets its name from the Roman king of the gods. Remember, Zeus was his Greek counterpart. And you can kind of see why they named after the king of the gods. It's just a massive planet, okay? So it's one of the gas giants, as we know, like we talked about, gas giants versus terrestrial planets. And we call these gas giants because you'll see pretty consistently they are mostly composed of hydrogen and helium. Pretty consistently. Okay, those are gases. Very lightweight gases, actually. Very low mass. All right, so out there, it takes sunlight a whopping 43 minutes to reach the planet. So not the warmest area. Okay, it's not a beach vacation. So one day, remember rotation versus revolution. We talked about that in the previous video and in a previous set of slides. Make sure you don't get those mixed up. So a rotation out there, so one day is 9.9 hours. So that's pretty fast, right? Your average work day, school day, whatever, is about 8 hours. So it's a little longer than that. One revolution, so a year, is about 12 Earth years. So that's kind of weird to think about. So, you know, again, birthdays would be way different out there. It actually does have rings. Now, most of the images you see, even the 2 I have on the screen right now, you don't see rings. So most people, when you say, okay, which planets have rings, are going to think it's a trick question because they only know of like one planet with rings, and you're probably going to say Saturn. Yes, Saturn has rings. Not questioning that. But the thing is, with all the other gas giants, they all have rings as well. They are just not as flashy. They're not as noticeable. And we'll talk about why Saturn's rings are so noticeable when we get there. But essentially, Jupiter does have rings. They are just dust, rock, you know, broken up bits, things like that. So they're not as obvious. Okay, you can look at the radius there. Again, miles and kilometers to help you put it in perspective. One of the best known features on this planet is, of course, the Great Red Spot, this gigantic storm that has been going continuously for over 300 years. That storm alone is 2 times the size of Earth. It is 300 miles in depth. So it's kind of in the same vein in the structure of how the storms are set up. You'll see they have like cyclones and anticyclones here. Kind of like hurricanes. Like, if you ever heard the term cyclone, a cyclone is almost like a hurricane, basically. It's, you know, it's got that characteristic swirl to it. So this one cyclonic storm on Jupiter is bigger than the size of the Earth. It has been raging continuously, so we're talking high wind speeds, pressures, all of it for hundreds of years. That's why it's so noticeable. Okay. Also on Jupiter, it is very, very high atmospheric pressure. So this is actually compressing the hydrogen gas into a liquid. That's how much pressure there is. T, what are you doing? Can't do anything. Oh my God. It's like they know as soon as I'm on the computer, they have to be like, oh, let me go do things I'm not supposed to do. Come here. Come sit with me and talk about Jupiter. All right. Because of this, it's a gas giant. Remember we talked about how you can land on terrestrial planets? You can't really land on gas giants. There's not a true surface. It's a whole bunch of different layers of atmosphere and clouds and swirling gases. And, you know, obviously the liquids from the compression and the pressure. So it's not a really good surface to land on. You're going to have a different range of pressures and temperatures out there based on what storm you're looking at, but anywhere from negative 166 degrees Fahrenheit to 2,400 degrees Fahrenheit. In these clouds, there's also this compound called ammonia. It's here on Earth. We use it for cleaning. It's got a very distinctive scent to it. It's also one of the chemicals you don't mix with bleach unless you just don't like being on this plane of existence. So don't mix ammonia and bleach. Don't mix them. Frankly, my rule is don't mix bleach with anything. Come here, doggies. Oh, you have. Oh, you're a fox. Okay, good. Okay. So if you've heard of the term jet stream before, maybe you've watched the local weather or something. They're talking about the jet stream and how it's affecting the weather pattern. There are jet streams there on Jupiter as well, but the difference is those are 2,000 miles deep. Hence all of the storms. Okay, you can see there are distinct color stripes here. So you can see that like, there's a white, and then there's like a tan and an orange, and like this reddish color. Those are what we call belts and zones. And each of the little kind of dots here, the different circles, those are all different storms as well. So one storm will be going like this way, and one storm will be going this way, and then you got the little circle, and that's another storm. There's storms on storms on storms. It's crazy. Okay. And part of why we get these bands is these clear separations in the storms, which one of it's your density and the different wind speeds and things like that, but also it's because the fast rotation of the planet kind of helps separate them out. Like think of like if you like spin something really fast, like if you're trying to separate like different liquids in solution or something, if you spin it like in a centrifuge in a lab, that spinning motion helps separate things that are different densities. Okay, kind of what's happening here. So we call them cyclones and anticyclones based on the direction of which way they're spinning. Generally speaking, the closer you are to the top, the warmer it is in those storms, with colder below. I mean, that kind of tracks what we know here on Earth. Hot air rises, right? This planet has a super powerful magnetic field. It is anywhere from 16 to 54 times more powerful than Earth's. So this is part of why Jupiter is not so good for humans. Okay, this whole situation leads to a very intense radiation, very similar to like what you would experience if you were very close to the sun. Humans and their physiology not so good with radiation, especially in high doses or for prolonged periods of time. So that's why we are not going to even try to go to Jupiter. Not that there's anywhere we could go, but you know what I mean. What's also cool about this magnetic field, so when it interacts with different particles and things like that from space junk, similar to how we have a magnetic field on Earth, and if it interacts with different types of energy and particles and things like that, you get the auroras. Like here on Earth, we have the northern lights and the southern lights. Well, Jupiter has aurora at the poles. That's what this lovely image is here. And it's so pretty to look at. All right, exploration. So despite the fact that Jupiter is not exactly rolling out the welcome wagon for us humans, we have sent a lot of spacecraft out there to check it out. So going back to the 70s, we've got Pioneer 10 and 11. Again, remember, think back to the Venus one. I mean, so there's like Pioneer Venus. This is the ones I don't want you to be confused with. They are separate missions, okay? So Pioneer 10 was a flyby that sent its last signal on its way out of the solar system in 2003. Pioneer 11, also currently on its way out of the solar system. We lost contact with that basically in 1995. The other two, Voyager 1 and 2, those are going to come up again with the other gas giants. These are also flybys. They are still sending information back to us, and they are in what we call interstellar space. So inter meaning between, stellar meaning star, so between stars. Okay, so they are still trucking along, and as far as we can tell, they're still doing okay. It's kind of crazy. It's, you know, that return on investment that NASA wasn't expecting with some of these missions. They did expect, you know, eventually this thing to peter out, you know, but it hasn't yet. It's kind of crazy. Also, same for Voyager 2. It's out there in interstellar space, having a good old time. We've also sent a mission called Galileo out there. You can kind of guess why we named it Galileo, because Galileo, he was super cool, and he discovered the 4 major moons of Jupiter, which we'll talk about in the slideshow next week. I don't know, sometime soon. So it was the first to orbit an outer planet. It also was launched from a cargo bay of the Space Shuttle Atlantis. That sounds familiar. And again, this is another time where NASA purposely sent the spacecraft into the planet to say goodbye to it. Now, whenever they do this, they always do this for the benefit of the longevity of the planetary system itself. Especially when we talk about Saturn, you'll see an example there. Is that they just don't want rogue, dead spacecraft running around. And if they can get any last data they can before they run it into the planet, bonus. Tut tut! Come here. Come help teach about Jupiter. Come here. Come here. Then we have Cassini-Huygens. Yes, that's how you pronounce it. This is back in the early 2000s, so it was a flyby. So the main purpose of Cassini-Huygens was to go look at Saturn. Come here! But the reason it stopped by Jupiter and did, collected as much information as it could was because gravity assist, helping get to the right place at the right time. Because remember, the planets are not all nice and lined up here and then here and then here and then here. Like, they're not like that. So we use gravity assist to get from point A to point B and kind of conserve resources, energy, things like that. What was cool is Cassini-Huygens sent back 26,000 images of Jupiter and its moons. 26,000. That's so cool. And then we have Juno. All right, this is artistic interpretation of Juno. All right. This was launched in 2011. It arrived in Jupiter in 2016. And if you know your mythology, you're kind of already picking up on where this name came from. So Jupiter was the king of the gods. We haven't talked much about the moons yet, but a lot of his moons are named after, how do I put this nicely for a high school audience? His close, special friends. Very close friends. I'm just going to leave it at that. Well, Juno was his wife, otherwise known as Hera in the Greek myths. Juno did not like all these extra close friends to Jupiter. So, she tried to intercede and things like that. Well, it's kind of funny because NASA's a little bit funny like this. So they named the most recent spacecraft to go and explore Jupiter after Jupiter's wife, to go check up on him and all his very close friends. Because when we talk about the moons, you'll see those names pop up. Funny. So it's when we have this return on investment. Sometimes these missions last longer. So they will break it into categories, like a primary mission of like when they expected the mission to be done, when they expected the robot to no longer be functionable. And that ended back in 2021, but Juno is still kicking. So they're like, cool, we're on an extended mission. So they're still getting data. It's really cool. It's Juno is out there to study the clouds, specifically the atmosphere, understand how it all formed the way it did. If you are eating something you are not supposed to, stop that right now. Again, here's a cool graphic I found for the Galileo spacecraft. You can kind of see the different points and the dates. Look at the different orbits. Check that out. Here's a up-close view of what the Juno spacecraft does and looks like. Here's a reference of a human for size. These things are huge. Like, when I was growing up, I had this idea of like these little robots we sit in space were like, like this big, like toaster size. No, these things are huge. Okay. Like the Martian rovers, I always pictured, kind of like little cars that kids can drive, like they have the big batteries in the back. No. Those things are like the size of minivans or bigger. Okay. These things are huge. All right, Saturn. Possibly my third favorite planet. I don't know, kind of middle of the day. This is our 6th planet from the sun, and it's our 2nd planet that is the largest in size overall. It is sometimes called the jewel of the solar system. You can kind of guess why it gets that name. It's got the most sparkly, wonderful, fantastic rings that we could definitely be able to see for a long time. Even the ancients, Galileo could see the rings of Saturn, okay? They're very obvious. We'll get into why in a minute. But that's why it earned the moniker of the jewel of the solar system. So this is the furthest planet you can see without a telescope. Now, is it super clear and distinct without a telescope? Well, not to my mostly legally blind self, but you can see it. Now, if you get a telescope out, then you can see the rings and the features and things like that. So this is, the namesake comes from the Roman god of agriculture and or wealth. Also, Saturn was the father of Jupiter. Okay, Saturn sometimes in some mythologies, there's a little bit of overlap into like Kronos, that kind of thing. There's different versions of it out there. So I just kind of stuck with what, the main NASA websites are saying. Okay, we are so far from the sun. It takes sunlight 80 minutes to get out here. 80 minutes. Because we are 886 million miles away. One day or one rotation is just over 10 and a half hours. It's crazy. That's a very fast day. Then 1 year, one revolution is 29.4 Earth years. So in my entire existence, Saturn has completed 1 year in spare change, basically. So when you look at the size of the planet, it is 9 times wider than Earth. It does have a tilt on its axis, just like Earth, so that means there are seasons. Now, I'm not saying those seasons are, like beach weather one day and not the next. It's dramatic out there, but they do have seasons. All right, just like with Jupiter and most of the gas giants, primarily made up of hydrogen and helium. The upper atmosphere, the winds, they can get up to speeds of 1,600 feet per second. That's bonkers fast. Okay. And here's why I said you need to know what density is. So Saturn is the least dense planet, meaning hypothetically, if it were physically a thing, if we can make a bathtub big enough to fit Saturn in it, of course, fill it with water, it would float. That begs the question, how large would the rubber ducky be? At least bigger than Earth, for sure. For sure. Has anyone done the math on that? Someone do the math on that. I don't know. Again, just like Jupiter, because it's a gas giant, there's not a true surface. It's layers of gas and atmosphere and swirling doom. Okay. Again, we have a lot of pressures and temperature extremes out here. Gets down to negative 288 degrees Fahrenheit, but all the way up to 21,000 degrees Fahrenheit, closer to the core. Okay. The gas, again, becomes a liquid. That's where we're changing states of matter because the pressure is so high. We know it's got a core that's pretty dense itself, but the core is made of metals like iron and nickel. We think there's a rocky or some similar compound around it. Again, they're still learning more about the outer planets. And one thing I did want to say is part of the reason we know so much more about the inner planets versus the outer planets. One, they're more habitable to us humans, and two, they're closer. Okay, it doesn't take 10 years to get out there. It takes 2 max. So what's cool is this is the 6-sided jet stream that's found at the North Pole. It also has auroras, which you can kind of see in this image as well. And so remember, jet streams are like fast-moving winds, right? They produce weather and things like that. So this particular area, we're talking 200 miles per hour. You can see the rotating storm there in the middle. This whole thing is 20,000 miles across. And just like with Earth, just like with Jupiter, there's a very powerful magnetosphere. So we get aurora when stuff interacts with it. All right, let's talk specifically about the rings. They needed their own slide because a lot of people, when they think about Saturn's rings, they picture just like a solid mass all the way around the planet. That's farthest from the truth. Okay, so it's actually a system of rings, and they extend really, really far away from Saturn, all the way up to 175,000 miles from Saturn. Okay, and inside these rings, you could actually hypothetically fly through them and things like that because it's not a solid mass. It is made up of gas and dust and rock, and the big kicker that makes them different, ice. Okay, the ice is what makes them so reflective. That's why we can see them so clearly from Earth. That ice comes from one of its moons that goes by the name of Enceladus. Okay, come here, come sit on my lap. Come. Oh, he's excited now. Oh, here we go. Here's a pug. Here's a pug. Whee! Okay, so the other planets with rings don't have this ice spewing moon, so that's why they don't have the sparkly rings, but they do have rings. So we're talking billions of pieces of ice, dust, rock, etc. They are going to range in size from teeny tiny little bits of gravel to, don't touch my keyboard, to rocks the size of like your house or bigger. Okay. And then intermixed into all these different rings, which are named alphabetically, generally speaking, the way they were discovered. So ring A, ring B, whatever. If you look at the picture here, it doesn't quite go sequentially in terms of like, if I were to name these from the jump and nobody asked me, A would be closest to the planet, then B would be the next, and so on and so forth. But you can see from this picture that's not how it is. But either way, they were named for how they were found. All right, and inside these rings are some of the major moons of Saturn, which again, more on that next week. So you've got Enceladus. There it is. There's Enceladus, there's Mimas, there's Dione, there's Rhea, Tethys. If you know your mythology, some of these names sound familiar. And what's cool about the rings is, again, they're not super thick in terms of like height. We're talking maybe 30 feet tall for some of them. and it's all broken pieces. There's movement between these things. We've got shepherd moons and the big moons, and each ring is orbiting at a different speed. It's going around the planet at a different speed. They're like their own little ecosystems almost. All right, exploring of Saturn. All right, so Pioneer 11, remember, we've heard about Pioneer 11 before. So in addition to checking out Jupiter, it also did a flyby in the 1970s of Saturn. This was the first time we'd ever seen Saturn up close. This is one of the images it took. So admittedly, that image isn't super fantastic. Wow, knock my socks off by modern standards. But think about that. That's one of the first close-up images of Saturn we had, taken by a craft in space. That's crazy. Okay, and then this is like an artistic interpretation of, Pioneer 11 now, all by itself, on its way out of the solar system. Then we have the Voyagers. We've talked about them a little bit before. All right, Voyager 1, it found 5 new moons hanging out around Saturn. It was like, hey, more moons, yay! Voyager 2 got even closer to Saturn than Voyager 1. It gave us more information about the rings, more photos of the moons, more information about all that kind of stuff. And then for a while there, we didn't do a whole lot with the outer planets because, again, it takes a lot of time, money, resources, etc., to get out to the outer planets. And we try to stay a little bit closer to home in terms of, human habitability. But we do need to know more about these things because understanding the bigger planets and where they came from and how they got there tells us more about the history of our solar system and even to an extent the universe and how things happen. So then we have Cassini-Huygens. So Cassini was the orbiter, Huygens was the probe. This probe actually landed on Titan, one of the major moons of Saturn. It's the one that's super cool. It's got a possibility for life outside of Earth because it has liquid on the surface. Notice I did not say liquid water. It's liquid methane. Okay, but biologically speaking, that is fascinating. So we are very interested in Titan. So Cassini-Huygens was a joint mission between the NASA agency, ESA, and the Italian Space Agency. It launched in 1997 and ended in 2017. It spent 13 years at Saturn. The whole reason it was there was to study the atmosphere of Saturn, figure out the different wind speeds, temperatures, what the internal core might look like, look at the rings, look at the magnetosphere, like all these different things. It's so cool. Now, it has what we call a grand finale. If you know what a grand finale is, maybe you're in theater. Okay, grand finale meaning it said its last bow. This is another instance of when we purposely ran spacecraft into a planet. But this was again for a purpose, kind of a double-sided purpose. One, we can collect more data as the spacecraft is running into the planet. In this case, we burned it up in the atmosphere. And two, remember Titan. Titan is one of the major moons of Saturn. Titan might have a possibility for life, either past or present or future. We don't want to muck with that. Okay, we don't want to contaminate it. So we didn't want this random dead spacecraft just roaming around Saturn because who knows what's going to touch it or get in the, we didn't want any of that. So the best way to protect Titan and any possible life that exists there was to burn up Cassini-Huygens in the atmosphere of Saturn. And I remember seeing a lot of social media coverage of this when it happened. A lot of the scientists, they spent their entire careers working on this mission, this one mission, because 13 years alone at one planet. They spent their entire careers working on this, and it was very sad. Like, they spent a lot of time and effort. I can't imagine that. Some cool images of, the Cassini spacecraft. You can see the little simulated drawing landing there on Titan. Okay, now let's get to Uranus. And yes, that's how you say it. Okay, I don't want to hear the other version because we're not in 5th grade, we're not in 2nd grade. We know. Okay, we have matured a bit. We're going to say Uranus. So, this is our 7th planet, our 3rd largest overall. It is a gas giant. Okay, it's also a subcategory called an ice giant because it's so gosh darn cold out here. It's icy. Okay, so what's cool about this one is for the longest time we thought Saturn was it. That was the end-all be-all planet. Stop there. But then here comes these telescopes that are getting really more advanced throughout time. And this guy named William Herschel in the 1780s found Uranus with a telescope. So this is the first planet to ever be found with a telescope. And back in this time, so think about your history, 1780s. What happened in 1776? Set of colonies wrote a breakup letter to a king by the name of George III over in England. For those of you who watch different shows on Netflix, this is like the Bridgerton era. Okay, connecting the pieces here. Okay, so because William Herschel was a British citizen back in those days, and even to an extent today, I would assume. I'm not British, I don't know. If you were a good British person, if you made a monumental discovery in science or what have you, you wanted to name things after your king or queen. Okay, that's how we got Virginia being named Virginia, named after Queen Elizabeth I, things like that. So he was trying to be a good citizen. He's trying to be a good British guy. He's like, okay, I found this cool planet. We have a new planet. I'm going to name it after my king. I'm going to name it Georgium Sidus. So Latin for King George, basically. And keep in mind, astronomy is not just only for the British folk. Okay, it's everybody. And the rest of the world is like, no. One, it breaks naming convention because all the other planets are named after, Roman mythology. And now we got George. No. Okay. So they made him change it. So that's where we get Uranus. Uranus was the Greek god of the sky. So yes, kind of merging Greek and Roman with the different mythologies and names, but they stole the Romans stole from the Greeks stole from the Egyptians, whatever. Okay. So they made him change it. Otherwise, we would have a planet George today. And that just does not roll off the tongue. So out here, it's so cold, it takes sunlight 2 hours and 40 minutes to get out there. So just over 2.5 hours. One day, one rotation, that's 17 hours. That's kind of comparable to our day. That's not horribly different. However, here's the kicker. 1 year or one revolution around the sun is 84 years. So about the average lifespan of an American citizen right now is about 80 years for comparison. All right, you can look at the diameter there. Basically, it's 4 times wider than Earth. And if you remember us talking like with Venus, we talked about how it kind of rotates backwards. Same thing here. Okay. And Saturn gets the prize for being the most least dense planet. This is the silver. Okay, they went silver. All right, and again, Saturn. I was thinking about Saturn. It's not Saturn, is it? Uranus does have rings. In fact, they come in 2 different sets. Sounds like a collectible. There's 13 total. Again, they are pretty faint. It's mostly rock, dust, gas, things like that. Temperatures gonna be around negative 224 degrees centigrade. This large K, that means Kelvin. It's another way of showing extreme temperatures. We get wind speeds out here up to 560 miles per hour, and they go backwards at the equator. Cool. You'll notice Uranus and Neptune both have a very distinctive blue or blue-green color to them. That is from the methane gas in their atmospheres. That the way light works and how things can be absorbed in terms of colors, like think about why plants are green. So it's absorbing everything else and reflecting that one color that we see. So like a plant is green because it's absorbing all the other colors of light and reflecting back that green. Okay. Same thing with the blue atmosphere, only it's absorbing everything and reflecting blue. Again, it does not have a true surface because it's a gas giant. It's also an ice giant. It's like a subclass of the gas giants. So we've got crazy temperatures, crazy pressures. You kind of see catching a pattern out here. All right. Leave your leashes alone. You're not going out right now. You're not going on a walk. It's dark. No. What's interesting though about Uranus is instead of spinning like a top as it goes around the sun, it orbits like a rolling beach ball. It's on its side. It rolls on its side as it goes around the sun. What we think in the formation of the solar system billions of years ago, what we think happened is something about the size of Earth ran into Uranus and knocked it off. It's like just knocked it like that. And it's kind of stuck there because, it's like a turtle on its back. It can't get back up. So it's got that distinction. It rolls like a beach ball. Make sure you know that. And this tilt, this extreme sidewaysness, basically, causes it to have extreme seasons. So when I say extreme seasons, I mean, at one point, half of the planet will be in a 21-year dark, cold winter. Straight. No breaks. Just 21 years of winter. It sounds like Game of Thrones. No thank you. Okay. And because of it's how it goes around the sun and everything like that, it's got a lopsided magnetic field, so the auroras are not over the poles like we're used to with Earth, Jupiter, Saturn, what have you. They're not, they're over like the sides. It's weird. Okay, here is an artistic interpretation of Voyager 2 reaching Uranus. So it did a 6-hour-long flyby in 86. That is not a very long time. I know it sounds like a long time, but we're still collecting tons and tons of data. And the further you are away, that further the distance it is for that data to be sent back to the scientists here on Earth. So while it was out there, it collected a whole bunch of time-lapse footage and looked at a whole bunch of rings and the moons and things like that. Most of the other observations and images you're ever going to see of this planet come from maybe the Hubble telescope, which is in orbit around Earth, and or space-based, or excuse me, ground-based telescopes like we have here stationed here on Earth. All right, Neptune. I know. Now we have our 8th and final full planet. This is the furthest full planet from the sun. It was named for the Roman god of the sea, aka Poseidon, if you're a Greek mythology person. And 3 guesses why. Look at that very distinctive blue color. Looks like a big old ocean. All right. Now, while Uranus was the first planet discovered with a telescope, Neptune gets the gold star for being the first planet discovered via math. They predicted its existence before they found it. I'm so sorry. However, there is a little caveat to that. Galileo actually did see Neptune with his telescope back in 1612. However, because it is so far away and moving so slowly, because 1 year out there is 165 Earth years, it didn't look like it was moving from our perspective here on Earth, so he called it a fixed star. Because it did not look like it was moving at all. So he's like, it's a star and it's not moving for some reason. So if you look through Galileo's journals, which still exist, you can actually see them at museums and things like that. You can see these notations of where he made these observations. But he didn't realize he was looking at another planet. Okay. And the reason they found this is because now we know about Uranus. We know it exists. We found it with a telescope. It's very exciting. It's not named Planet George. We're very proud of that. But they noticed, based on the math of how orbits work, which we'll get into later, Uranus was not going the way it was supposed to. They're like, what's wrong with this planet? They're like, oh, something else must be out there messing with the gravitational pull, something big. Okay, so that's why they did the math, they kind of reverse engineered it and figured out there's something massive out there. It's got to be a planet. Then they knew kind of where to look, and then they could officially go and discover it. Hence, it was officially discovered in 1846. All right, sunlight takes a whopping 4 hours to reach out here, because we are 2.8 billion with a B miles from the sun. 1 day is 16 hours versus a year is 165 Earth years. And again, Pluto also has an eccentric orbit. That's why it's no longer a full planet, or part of the reason anyway. And so there are times when Pluto's orbit crosses Neptune's orbit. Pluto is closer to the sun than Neptune, so Neptune actually becomes further than Pluto. And again, it does have an axis tilt, so that means it does have seasons. Now, these seasons are, again, very extreme, very long. Some of these seasons last 40 years. All right. Of the giant planets, it's the most dense. Most of its mass is this, again, why we call it the ice giant class. It's a dense fluid of icy materials like water, methane, ammonia, things like that. So basically, Neptune and Uranus, between the methane, the ammonia, all that stuff, they don't smell great to human noses. I'm going to tell you that right now. Yes, there are jokes there. No, I'm not going to say them. We think there might be a small rocky core. Again, more research is needed. It kind of, it's hard to get funding for missions that are only specific to some of these outer gas giant planets. So that's why there's not just a ton of dedicated missions only for them. Again, no solid surface. We know the blue color comes from that methane. It's a very distinctive color. It also gets the prize for being the windiest world. Now, we talked about Jupiter having strong winds. We know here on Earth, especially in Oklahoma, we have strong winds because those are nothing. The winds out here on Neptune are 3 times stronger than Jupiter's. And of course, way, way, way stronger, specifically 9 times stronger than Earth's. So I don't know what song they would write like they did for Oklahoma, but I'm sure it'd be a more extreme version. So Jupiter has a great red spot. Back in 1989, they spotted a similar storm on Neptune. They called it the Great Dark Spot. Fantastic naming. Shockingly enough, it was a spot and it was dark. Oh. But actually, unlike the Great Red Spot, it has since disappeared. So kind of interesting. So that shows us more about the dynamics of how the atmosphere and all that work out there. And again, that storm was much bigger than the planet Earth. Neptune does have rings, the main rings. You can read those names there. I'm not going to butcher those names. A lot of them are French, and I don't want to mispronounce them because I didn't learn French. I learned Spanish. It does have 4 ring arcs, which are mostly clumps of dust. We call those liberty, equality, fraternity, and courage. And again, it does have a magnetosphere, so we do get auroras out there. And we captured the first images of those back in 2023 with the James Webb Space Telescope. Excuse me, I need to move. There's a pug on my arm. Okay, for exploration, the big one is Voyager 2. We sent it as a flyby over the North Pole out there. It was the very first mission to make it out there and explore the planet up close. While it was out there, it also flew by Triton, which is the major moon of Neptune. Again, keeping with the naming convention, Triton is the son of who? Poseidon/Neptune. The Voyager mission also confirmed that there are rings out there. Again, they're not flashy. They're not like Saturn's, but they do exist. And what's interesting about these missions is, especially when you're talking flyby, so limited amount of time to capture images and send them back, right? Well, think about if you've ever tried to take a photo with your iPhone or iPad or whatever in a very dark room. It'll kind of have you like hold it there and kind of freeze while it captures the image. And it'll kind of do this thing where it does like an exposure at the bottom, where it's collecting as much light, as many photons as it can, so that your photo comes out. Same thing is happening here. There's so little sunlight out here, you need longer and longer exposure times to get these images of the planet or its moon or whatever. And so that was affecting how many images it could take and send back, especially with such a limited amount of time. Then later on, closer to modern day, Hubble and the James Webb Space Telescope, we have collected a lot more images with those space telescopes, and they can tell us a lot of other things too. Why isn't it? Okay, so here's some cool images collected over the years so that was the Great Dark Spot there. It's since disappeared. These are some of the really early images. Again, they're not great. These are some of the early images of the rings, but again, you got to talk about low exposure, very little light, and 1970s technology. So don't judge too harshly compared to, your modern iPhone, whatever number we're on. All right, you can kind of see the flight path here, Voyager 1 and 2. Look at all the different orbits of the different planets. You can see they went on slightly different trajectories. Okay, so they're not hanging out together, going on a road trip out of the solar system. They are not anywhere near each other, right? Okay, and yes, Pluto is a dwarf planet, but I felt bad not putting it in the slides because Pluto does have some cool qualities, and I also did not want to get griped at by children who were like, "But Pluto, my favorite." So here you go. All right, so it became a dwarf planet officially in 2006. We also call it a Kuiper Belt object. Sometimes we call it a trans-Neptunian object or even a Plutoid. Whatever, use whatever title you like. I'm cool with all those. It was actually discovered in 1930, so that's pretty recent when you think about it. Just under 100 years ago. So we're coming up on its anniversary. What should we get? I don't know. So actually the name was picked by an 11-year-old girl from Oxford, England. We know, of course, Pluto was the god of the underworld in the Roman mythology, aka Hades in the Greek mythology. And so basically she heard about the discovery of this planet. They were like announcing it over the radio and stuff, and she was having breakfast with her, I think it was her grandfather, and she mentioned, "Oh, I heard about this planet, they should name it Pluto." And so he got a hold of the observatory and said, "Hey, this is what my grandkid said, just, here you go, tossing it out there." And they're like, "That's a great name." So she actually got the credit for naming Pluto Pluto. She did not find the planet, no, but she got to name it. It does have moons, okay? It has 5 moons, all named after other underworld beings and entities like Charon and Cerberus and things like that. It doesn't have any rings. Now out here we're talking, you know, negative 375 degrees Fahrenheit to negative 400 Fahrenheit. That's not a huge difference. I mean, it's cold or colder. Ooh. For comparison, liquid nitrogen, the stuff that you can like freeze dry stuff in real fast, like maybe the cheese puffs or you saw it at the mall or something like that, that is negative 321 degrees. Okay, that's why when I work with that, I have to wear like really thick gloves and all that stuff. So we're talking colder than liquid nitrogen out here. And interestingly enough, the atmosphere does have some nitrogen. It does have some methane, some carbon dioxide. It's got a lot of frozen surface features. All right. And that nitrogen is actually frozen to the surface. It's part of why it's so far out here is there's very little sunlight. None of that ice is melting anytime soon. So that's why the temperatures are so extreme. All right, the orbit is again weird. That's part of why I got demoted. So it doesn't take this standard elliptical shape of an orbit. It goes more of an oval shape. So that's why it ranges in distance, where we go from 49 AU to 30 AU. So they call it the average of 39 AU, kind of meet in the middle, basically. If you are a photon of sunlight, you're going to take 5.5 hours to get out there. And again, it does cross the Neptune orbit every so often for about 20 years at a time. The last time was 79 to 99. So as of right now, Pluto is the farthest out there. Okay. And one revolution is 248 years. So even since we discovered it in 1930, it has not had one birthday. We can look at the anniversary, I guess, of discovering it, but it hasn't had a birthday. So sad. So it is about half the size of the United States. So we're not even comparing it necessarily to the size of the Earth. We're comparing it to the size of the United States. That's how small this thing is. All right. It is also smaller than our moon, which means it has less gravitational pull, less mass. One day is 153 hours. That's a very long day. And again, like Venus and Uranus, it does have that retrograde rotation where the sun rises backwards to how we know it here on Earth. That's cool. And again, it's got mountains, valleys, plains, craters, etc. A lot of icy surface features. And this is an artistic interpretation. You can see that's its major moon Charon there. That's another moon over there. To explore Pluto, we have launched specifically the mission called New Horizons. It was launched in 2006. I mean, it takes a good 8-9 years to get out to Pluto. It's so far away because we cannot go the speed of light. That's not physically possible yet. If it ever will be, I don't know. So that's why it takes things so long to get out there. Okay. So we did this mission and it got there in 2015 and it did a flyby. It wasn't hanging out for long, but it took a lot of good, really close up, good images of Pluto. That's where that characteristic like heart image comes from, where you can see the heart. That's where that image comes from. It's from New Horizons. Before then, we just had really blurry, really pixelated, grainy images of Pluto. And they weren't great, so we couldn't tell a lot about it. But then we send New Horizons out there. We get really clear images. We get some good clear images of, especially its major moon, Charon, there in the corner. And it also took some images of this other object here, which is called a Kuiper Belt object, KBO, Arrokoth, also in 2019. And New Horizons is also currently on its way out of our solar system. Okay, another thing I found online just for you to check for reference. I really need my arm, I'm sorry. I love you. I love you. Go too. So you can kind of see in terms of putting the planets in order by size compared to the sun, right? There's another way to look at it, kind of humbling. Here's Earth. Here's the moon. Here's Mercury. So I know it's probably more information than you ever wanted to know about all the planets. And again, that's not even all the stuff I could have said. This is me trying to be brief. You saw how well that worked. So hopefully this helped. Let me know if you have any questions. Make sure you're keeping up with your guided notes and all that stuff. And here is Tut saying goodbye. Say bye-bye. I was taking a nap. I know, you're so abused. Just interrupted your nap. I'm so sorry.